Good afternoon to everybody, at least on this side of the world, and good morning at the other side, or even good evening. Good to have you all again in this webinar. Last week we had this webinar on NAV on-premise and in the cloud. Today, actually another topic, but you could say on the other hand, for new years or new technologies, new things, now this is a very important one to get into. Continuous integration. How do you get your code, let's automatically update it and deployed? I've got two speakers today, Richard Robertson, or Richard in English, and Ron Koppelaar, two Dutch guys. Yes, there are a lot of Dutch guys at the moment, and so from all around the world you're invited to step in for another webinar if you have an interesting topic. Richard and Ron are both colleagues at Segeka DSA, a Dutch partner, Dynamics NAV partner, which has developed an add-on for housing corporations. And a couple of years ago, it was a merger, this company bringing two techniques together from the AX and NAV side, and they wanted to get into a better, let's say, software development practice than what we're used to. So they started to use TFS, etc. And later on, they really got some things nicely running. And that's what they want to show to you today. They had a presentation on the Dutch Dynamics community event a couple of weeks ago, and it was well received, I think. Unfortunately, I wasn't allowed, I wasn't able to be part of their presentation. So surely I'm happy to have them on our webinar today, even it was just for myself, but I hope you all can profit from it. Before we start, and I'll give the presentation to both of them, I'll have a couple of things, as you know, some housekeeping rules. This will be recorded again and will be published on Mark's YouTube channel, often within a couple of hours, maybe otherwise next morning, but surely quite fast available for all of you. So if you have missed anything during the presentation, of course, feel free to put questions in the question pane. Yes, if you have, do, and I will have a look at them and pick them up and step in to pose them to Richard and Ron. But if you find out later, hey, what the heck, I missed something, of course, go to YouTube and replay the whole thing. So use the question webinar window. And of course, like always, a very big thank to our sponsor, Liberty Grove, and especially Joe Mattis, who is supporting us today from the technical side. Thank you, Joe. Next webinar, we're always looking for presenters, and maybe you. At the moment, we have nothing on the schedule yet. We're talking with a couple of people, and of course, we have a summer recession, so we will be picking up things after summer vacations. If you want to know which one will be ahead, you can always go to our website. This one is already scheduled. You could say rescheduled, moved to the 21st of August, number 7 in our 101 series. And we're working on the next, the soon to be published, and will probably start in September. So if you want to be in the know of what is happening, we have a newsletter, and if you haven't subscribed to it, use this very readable link. And of course, I'll keep a little bit talking more that you can write it down. Well, of course, you can look it up in the recording on YouTube later. So that's it from my side. And of course, I will be moderating your questions. So the floor is to Ron and Richard. I'm going to change presenters. So guys, pick it up and have a lot of fun.
Thanks, Luke. So let's get started straight away. Is everything clear?
Yes.
I assume so.
Yep.
Let's start. Start with a short introduction about ourselves. Obviously, as Luke already said, I'm working as a software engineer for Segeka DSA in the Netherlands. I also have my own blog. It's the navblog.com, so make sure to also subscribe there. I'm also the creator of the NAVBAS Git VS Code extension, which we will use throughout the webinar. Ron?
Okay, my name is Ron Koppelaar, working as a senior software engineer, and for the last, I think, 4 years, I was involved heavily in automating our development process related to NAV. Okay. Let's have a look a little bit at the company that we're working for. It's, as Luc already mentioned, Scheka DSA. We have actually one huge solution called Dynamics Empire, which is a vertical solution built on NAV for the real estate market, and in particular social housing as we know it in the Netherlands. The solution is based on NAV 2016 and NAV 2017. So actually, all our customers are on the on the same almost same major versions. We are a development team of approximately 22 developers located in the Netherlands and in Romania, Bucharest. And well, with this team of developers, we deliver monthly service packs on our solution, and those monthly service packs mainly containing legislation changes, bug fixes, and some new features. And of course, all those service packs are delivered in an automated way from starting the development until the release part, which is an MSI that we ship to our customers. Besides that, so for the on-prem, we're still working, it's business as usual. On the other hand, we're also working towards Business Central for our solution, and for that we are in a program together with Microsoft, the Ready to Go program that we started in, I think, recent February. And because we have a quite large solution, we were not able to move everything into extension V2 by the end of this year. So with the embedded app solution that Microsoft is providing for Business Central, we are able to do this in a more hybrid way, so having both CAL and AL development. Looking at the solution, as I said, it's quite a large solution. We're talking about NAV 2017. You have 5,700 objects in standard NAV. From those, we modified 760 objects. And besides the modification of existing NAV objects, we also added a couple of objects, meaning 4,700. So looking from a solution perspective, you can call it huge. Okay, that's a little bit about our company and our solution. The agenda for today, going to talk about a continuous integration. So what is a continuous integration? Which components are made up? So the pillars of continuous integration, actually. The tooling, we use Visual Studio Team Services for implementing our continuous integration. So we're going to show that one. We explain how you can implement or do development and Git integration with an NAV 2016 or 2017 environment. So it's not about new stuff, but also in the old stuff. You can do a proper Git integration.
It's actually for every version that has a Docker image.
Yep. And we're going to show you how you can migrate your existing solution to Git and to VSTS. We show a little bit about the development process. So according to Wikipedia, what is continuous integration? Well, it's a practice of merging all local development copies of several developers into a central environment, and do this several times a day. So continuously getting all the pieces everybody's worked on in one central environment. Okay, then the components about continuous integration. To practice continuous integration, you need some things in place, and one of the key things that you need is source control. Obviously, if everybody's working locally, you need some management tooling, and well, source control will help you on that one. Build automation. If everybody's doing things locally, a central way of building your stuff should be in place. Test automation. Well, if some of you listen to Luke the last couple of years, he was one of the evangelists also about test automation, and well, he's definitely right on that one. And you also have something like automated deployment. It's continuous delivery. Actually, it's a thing that we practice here at Segeka DSA, but we keep it out of scope for this presentation and focusing on the continuous integration part. So source control. What's source control? It's several purposes. One of the purposes for source control obviously is a safe location where you can store all your sources, your most valuable assets actually as a software development team. You can store it in a safe location. It's a mechanism to collaborate on the same objects or the same source files together with a development team. So you could imagine that everybody's multiple developers are working on the same source file, and if you don't manage that with proper source control, you will be overriding each other's changes or lose track of them. So it will assist you in merging changes from different people into one central location again. Another thing is multiple versions. If you have an ISV solution and you have multiple versions that you need to support, also the version control can help you by developing in one version and merging changes from one version to another version. One of the main things is tracking changes, making changes to source code. You want to keep some kind of history and see who changed what, when, why. Obviously, you can put that in the documentation part of your NAV objects, but that's not the best practice, to my opinion. For that, you can use source control, where you can put all those information in. And the good part with source control is that you can also do compare between current version, previous version, or whatever version. And if there are issues, you can also restore a previous version and use that one again. It's actually mandatory for doing continuous integration, because if you want to collaborate with more than one person in your code base, well, you need to have this in place. There are multiple providers for source control. You have SVN, TFS, which is the old source control management system coming from Microsoft. It's still support, but not, I think, used by them themselves. And well, the industry standard actually is Git, which is heavily used all over the place. Next component of the continuous integration is build automation. A build automation is actually a central point and a build server where you automate your process of compiling and building your solution. Preferable you do this after each change. If a developer make a change to the source code, you check it in your source control system, and it will on a central server there will be a build triggered, and your code is compiled and validated. And the good part is that you get actually instant feedback from this build machine. Within a couple of minutes, actually, you should get feedback if your code change was okay or not. And this build server can be used for, of course, for compiling and getting the compile issues. One of the most common things that you hear, it works on my dev box, but in a central or in another environment, it doesn't work. So that's where a build server can help you, that everybody, that all source code is built in the same way, in the same manner, with the same dependencies. It can validate for guidelines, especially if you go to AL development. There's a proper way of showing all the things that should be in place. Of course, it's the place for running automated tests. So it's besides compiling and building, the build server can also be used for running the automated tests. And in the way we implement it, we have actually two build types. It's a full build and incremental build. The reason why we make this distinction is because a full build can run for quite a long time. It builds the complete solution from scratch. So it takes, if you look in the NAV environments, it will take a Cronus database and start importing all your modified objects, run a full compile, then run all the available test code units there are. So if you also run the test code units from standard NAV, this could take a couple of hours. The incremental build, on the other hand, is something that could run right after you make code changes, and that build should be done in a couple of minutes, max. Let's say 50 minutes. You should get feedback that you broke something in the software. That might be one of a compile error, but it also might be failing tests. So the incremental build is, it's important that you get very fast feedback to the developer. To get this all up and running, of course, you need some tooling for automated building. You can use VSTS, so Team Foundation Server, but there are also other free available tools like Jenkins, which is an open source, I think Java-based platform. We used that in the past before we moved to VSTS. Next topic is the test automation. There is a test toolkit available. It has been there since NAV 2009. Microsoft is delivering the test also together with the Cronus database. So to see if you don't break the standard functionality of NAV, at least you could start running those tests to see you don't break anything. And besides that, we think it's a very good practice for everything you implement, that you also write your own test code units. I mean, otherwise you need to test it anyway by hand, but having automated tests, you can run them over and over again. And as we implemented it in the full builds, the tests are run every night, and during incremental builds we run the tests. At least the code units were based on code coverage. We see which test code units we need to run, and then also the test code units are executed. Often you see it as overhead, but in the end it will pay off during maintenance on your solution. Okay. Then the tooling. As I said before, you need tooling for all those components that are made up for a continuous integration. And there is a tool available. It's VSTS, Visual Studio Team Foundation Server. It's an online tool that covers not only continuous integrations, but actually the complete development life cycle. So from building, source control, until release management. It's free. At least if you are with a small development team, until 5 developers, you can just sign up for Visual Team Services and start right away. It has source control providers for multiple actually multiple source control providers. You can use TFS, you can use Git. I think there are even more providers available that you can plug in for your source control management. Obviously, we are using Git as it is the industry standard. Create, build, and release pipelines, which we're going to demonstrate. Of course, it's not only PowerPoint this afternoon. So stay a little bit close with us to walk through the slides, and then we get to the interesting parts. Automated tests are covered by VSTS. There's some wiki functionality, so you can document everything you do in your development process. It also has support for Scrum and Agile, so work items, sprints, dashboards, etc. And of course, if you're using that, you also need some reporting about the items that are still in progress or what have you. So some management reporting is also there. So I really I don't have stocks, so to speak, about for Microsoft the VSTS, but it's a very good tool. It's online available. It gets a very frequent updates. They heavily invest in this tool. So I really would encourage everybody to start using. If you want to look at continuous integration, and move to VSTS.
All right, so how will we integrate our NAV development with Git? Well, the classic problem that you have with NAV development is that you're working in your database and not directly on your source files. So the database must be kept in sync with the source files on disk. And in order to do so, I've created a Visual Studio Code extension to actually do that for you. With that extension, you can easily create Docker development containers and directly integrate them with source control, especially Git actually. This was my project that I did in my free time. So after a couple of weeks, I came to this extension, which was quite well received at the Dutch Dynamics. And I also got some great feedback afterwards, so keep the feedback coming. Of course, you can find it for free on the Visual Studio Code marketplace. And of course, the suggestions and bugs can be reported on GitHub. It's very easy to set up. Just a few settings that that will actually be done with some assisted setup actually. The benefits of Docker, if you missed that, there's no need to have local NAV or SQL installations anymore. You can run multiple major, minor, and localizations side by side. And the creation of a new container is very easy. It only takes between 1 and 2 minutes. It's very easy to throw away your container and start with a fresh one. You can also create a repeatable and identical development environment for all developers to avoid it works on my machine scenarios. So how do we do that? We will start in a bit with creating a new repository in VSTS. We will clone that to my local machine. And cloning is actually pulling a copy of the central Git database. Then you need to export your modified objects. So I assume you have a database with other modified objects in it. You have to export your modified objects with the export NAV application object commanded. You can add some additional filtering to only export the objects that you modified, because that's what we want to store in source control. Then you have to split them using the split NAV application object file commanded. And then you will have those text files per object, which we will store in Git. I will move those source files to my local Git repository, stage and commit them, and then push them to the remote. And the remote is in this case VSTS hosting our Git database. In order to demonstrate this scenario, I've created some kind of demo application. It's not about the application, but just to demonstrate it. It's the well-known item classification table. with a code description and the ranking. I've added a field to the item table, the item classification code. And whenever an item is inserted, it will assign the classification code with the lowest ranking. And well, this behavior is validated by automated tests so that we're sure that it keeps working. And if I do development, the build will actually verify if everything is still fine. So let's start with some demos. We're going to head over to VSTS. I should stop the PowerPoint. All right, so we're in VSTS right now. I'm using the new user experience, which is a bit, well, unstable sometimes, but I want to get used to it anyways. We're going to create a new repository. Let's create a new one. Let's call it nav skills. Create. All right. Let's open it up right here. As you can see, the repository is empty, and I'm now going to clone it to my local machine. And to do that, I'm using Visual Studio Code, but it also can be done with the command line, obviously. So git clone, paste in the URL. So where do I want to store this guy? Nav skills demo. I'm going to open the repository. Why not? So we have an empty repository. I'm now going to set up the VS Code extension that I've created. And it can be done with the go command, as you know it from AL. I will select my Git repository, select my development license, and then it will install the required modules from the PowerShell gallery, so you don't have to worry about it yourself. And that's already been done. Right now.
Question, Richard. You already installed the Visual Studio Code extension?
Yes, I've already installed it to just save up that little bit of time.
Yeah.
I've also exported the demo application objects so that I can easily, well, move them to the Git repository, which is here. It creates some default folders for me. That's actually what the go command did. These folders can also be changed in the user settings of VS Code. So back in VS Code, I will stage and commit my objects. Finish the commit. And I will push them to VSTS, which can be done either by clicking on this little thing over here or just using the git push command. All right, so now my code is safely stored in VSTS. And I've already created a Docker development container to also save a little bit of time because you don't want to wait 1 or 2 minutes during a demo. I will now synchronize my container to make sure it has the latest objects. As you can see, the extension contains a few commands. Well, I will not go into detail that much right now because it's all well documented on the wiki that I provided with the extension. Choose my container. So this command will actually check if there's anything to export from the NAV database and if there's anything to import from the Git repository or if there are objects to delete. You can see the output over here. Currently, there's no commits found yet, so my container is still fresh. And I stored 6 objects in Git, which it's importing right now. So it's finished importing, it's compiling the objects, synchronizing the schema. Now my Docker container is ready for development. And we're going back to the slides. So demo recap, we created a new Git repository in VSTS. I've cloned it to my local machine. I've executed the go command to set up the extension, where I had to select my Git repository folder and my development license file. I've moved the sample app files to the modified folder. I've staged and committed changes to my local repository. Then I've pushed the commit to the remote, which is VSTS in this case, but this could also be GitHub or whatever. And I've synchronized my container with the sync command. So setting up VSTS, there are still two things that we need to take care of before we can implement continuous integration. We have to set a branch policy. You can use the branch policy to make sure that no one else does development directly on the main branch, only on feature branches. And this is done to keep the main branch as stable as possible, so that you don't allow people to break the main branch, because that's the branch where you will deliver your solution from. This also enforces you to use pull requests. A pull request is actually a proposal to include the changes done in your feature branch in the main branch. You can set a merge strategy, for example, squashing the commits. So let's say you did 10 commits locally, and in the main branch that will result in one commit that actually is a merge of all your changes, so that you keep a nice and clean history. You can set a number of reviewers on the branch policy. This is actually used to force a code review by someone else, so that you always have that extra set of eyes to look at your code. You can also automatically assign a group of people that are allowed to do code reviews to the pull request. So whenever I propose my changes, my colleague will get a notification to have a look at the code. You can also link a build that'll run whenever a pull request is created or when a pull request is updated. If things are not really clear right now, don't worry, I will demonstrate it in a bit. We also have to configure the builds. I've already prepared the builds because it takes too much time to configure those on the fly. They just have to be linked to the Git repository that I've just created. The builds run on an agent. This can be a hosted agent or a private agent. With a hosted agent, you don't have to provide the server and install the agent on it. It's actually Microsoft taking care of this in the background. If you want to use a private agent, you're supposed to provide a server with the VSTS agent installed. That's actually the scenario that we're using right now. Ideally, you would want to use the hosted agent, but unfortunately, it's a bit of a hassle right now because we need Docker images on the machine itself, and it takes a long time to download them for every build. So straight to the demo again. Let's head over to VSTS. And let's first configure the build.
First show the files that you just stored in the Git repository?
Yeah, sure. So this is where my files ended up. Yeah, you can also have a view on the history over here and see what everyone did. But ideally, you will do that in VS Code or, well, another Git provider. Configuring the build. Let's open it up. We're not going to talk about the build steps right now, but we'll do that a bit later when the build is running, so we have some time. We have to link the build to the repository that we've just created. It's nothing more than that. We can then head over to the branch policy. So here I have an overview of the branches. I only have one, which is called the master branch. And that's the default branch that Git creates for you. But you can also create other branches, give it a more descriptive name. So branch policies. So here we'll see the options that I just spoke about. We can require a minimum number of reviewers. We're actually having this set to 1. There's also an option to allow users to approve their own changes, which is a bad practice, obviously, but for demo purposes, it's quite handy. This is the option about the merge strategy. You can use a squash merge, so condense all the changes in a pull request into one commit with one paragraph. And we can add a build, which is the build that I've just configured. It's called NAV CI. There are a lot of more options here, but I won't go into detail right now. All right, so the branch policy is all set up now. As you can see, the NAV CI build is enabled and it triggers automatically. Let's save that and go back to PowerPoint. So the development process.
Yes. Yeah. Now that we actually set up a couple of things, so we create a repository in Git. We set up the builds. So yeah, everything is ready to go to start developing. So yeah, development process. How does it look like? If you work in Git, yeah, as you saw with the creation of the repository, it's you have local and remote. It's a distributed source control management system. So every development is done locally. Every developer has a local environment where he has a Docker image, where he has the Git integration, where he has his development tooling, etc. But yeah, a way of working with Git, a good practice with Git is actually that when you start developing, the first thing you do is create a feature branch. And a feature branch is yeah, to isolate all your changes that you are making to one single branch. And yeah, within Git, creating a branch is only a split second. If somebody ever have worked with TFS, you know that creating a branch can take up a while because you're coupling all the files and creating a new workspace. In Git, it's just a pointer in the Git repo that says, okay, this is a new branch. So you're always starting every new development. Each individual development task, in our case, is a feature branch. Well, as soon as you have created your feature branch, you can start developing. In our samples today, we're going to show development being done in CAL, in C-site, using CAL, working in C-site. So you start developing. Yeah, when you're done with developing, you do some local testing, of course, using either web client or still a good old RTC. And then the next step that you do is you sync your container with Git. What does it mean? It will export and import changes made in your container to your local Git repository. When the changes are made to Git, there will be a commit. A commit is actually the check-in from TFS, and we need to push the change to the remote server, the remote origin. In our case, the remote is VSTS, and what will happen there is that you need to create a pull request. As Richard already mentioned, the pull request is actually a request that you say, I have a change here, a code change in my feature branch, and I want to publish this change into the central repository. And because we put this this branch policy, the only way to get our changes into the master branch, we need to do this via a pull request. And in our case, two things will happen. One, if you create the pull request, the code review must be done. It's just a manual step that somebody else will perform a review on your code changes. And in parallel, also a build is triggered, an incremental build in this case. And if both steps are completed, your code is merged into the master. And if either of those two steps is failing, your pull request is just pending to be solved. And yeah, the good part is because we created the feature branch, you don't mess up the master branch. It's still isolated piece of software. So that's basically the development process, which Richard now shows in practice by making some code changes to the sample application we initially uploaded now to the Git repository.
All right, so back to VS Code. So as Ron said, the first thing we have to do is create a feature branch. I usually forget that, so I end up with a local mess. But let's be brave and just do that. It's good practice to always give the feature to start the branch name with the main of the master branch. In this case, it's also called master, and I will call it my feature. All right, so let's head over to C side. So within one of the sample objects, the item subscribers object, where it actually triggers from the oninsert of an item, it sets the correct classification. So, but I think this parameter name rec makes no sense, right? Because we're in a code unit and we just want to name it item. So let's do that. Right, so nothing special, everything compiles. Go back to VS Code, synchronize my container, so it will export the object that I've modified. One object to export. It's also taking care of the modified property. Please provide a commit message, so I changed the rec to item. Okay, let's get rid of this one. So it successfully synchronized my container, and we now have to actually push my feature branch to VSTS, because right now VSTS has no idea about my branch called my feature, because it's just local. So we can either do that by using this little thing over here, or using git push. You see it's still pending. All right, so back to VSTS. Go to the files, and it'll show that I've updated the branch master my feature. And it directly asks me if I want to create a pull request. Well, let's do so. Here you can see that it will include the changes done in my feature branch in the master branch. And here you can actually see the div on the object. You can also give it a descriptive, a more descriptive description. Let's create the pull request. And the build is already queued, and it's running right now. So let's have a look at the build. Still have to get used to the new user experience. It's completely different, so forgive me. So now we have time to have a look at the build steps. The get sources is just a standard step that will take the sources from Git and download them to the virtual machine. Downloads my build scripts, from which I store it on the Azure Blob Storage. It creates a container, which usually is a bit slower than this, but I speed it up a little bit by preparing that. Importing the object succeeded, compiling the object succeeded, but hey, something went wrong here. Let's deep dive a little bit into that error, and we'll see that on this line, the following event subscribers are inactive. So code unit 60,000, only for insert, error parameter mismatch. So because of my change, I actually made an event subscriber inactive. The object, of course, compiled just fine. A build is really something to catch those things.
Well, as we say here, if you break, you fix.
Yes. So let's go back to C side and clean up the mess I've made. Let's first change it back to rec. All right. And there's something else I want to change. I don't want to use the item classification with the lowest ranking, but I want to use the one with the highest ranking. Well, that can be simply done by changing this find first to a find last, just for the purpose of this demo. All right. Let's leave C side and synchronize my container again. So what did I do? Item back to rec, and I've changed the find first to a find last. All right. As you can see, I have one commit locally that needs to be pushed to a VSTS. So let's do that. All right, go back to the pull request. This build failed, so we can forget about this one. As you can see, I've updated the pull request. You can see that over here. You already see that there's a new update just now. And we can see the diff on the compared to the previous commit I did and to the last commit I did. But we can also see an overview, so of all the changes. And then you only see that I've changed the find first to the find last, because I've already reverted my first change. If you go back to the build again, so all the build steps are actually done by custom PowerShell scripts running against a Docker container. Unfortunately, VSTS has nothing in place for this, so you have to do it yourself. So it already passed the test for the inactive event subscribers. So my event subscriber is working again. Meanwhile, it's synchronizing the schema changes, which requires a restart of the service tier, unfortunately. It's has something to do with Docker. It's just something we can't help. It's currently starting to run the automated tests, which will start a client session in the background, create a test suite, and add all the automated tests. In this case, I've added a filter on that so that it will only execute my tests. But starting up that RTC client takes a while. So everything is running on a virtual machine I've created in Azure, and it's actually a server 2016 with containers. And meanwhile, it finished running my automated tests, and something failed here. So if we have a look at the tests, you can see that I broke one of the tests with my change. So this could mean two things. So either we have to adjust the test as well, or my code change just broke something, broke a functional thing. So those automated tests really add value, especially if you run them in an automated way. It even adds more value if you run those automated tests whenever someone changes the code.
Richard, if I may step in with a question from Tobias Venster. By the way, he's giving you a compliment on the extension for VS Code. But his question was that in building all this, did you consider using Docker tasks in the VSTS builds?
Yes, go on.
Yes, so you consider that, but you're not using them?
Currently, we're not using them. The situation that we have right now is that we create the container just by using PowerShell, and then for every build step, we have a separate PowerShell script that uses modules and stuff like that. It's we think that's a better way to organize it. However, what I would like to change in the future is that when the Azure container instances, well, they already are there. but they will become a lot faster when the Docker images are replicated to every data center. Then you can spin up a container instance in, well, just as fast as you would do it on a VM. And then, yeah, we would really consider changing that.
Okay, thank you. By the way, why do you call the extension NAV BAS, B-A-A-S?
It's actually hinting to another thing that I'm working on. But it's still work in progress. So
you don't want to you don't want to unveil the meaning of BAS.
Not yet.
Oh, that's a good one for our next webinar.
Yes, yeah, definitely.
BAS continued, and while asking this anyway, and that was the major question actually. So this one looks nice. Let's say working with CAL. How easily can you get this? So let's say switched into AL?
You mean the build part or?
Anything. I mean, it seems to me there are no restrictions, but is there anything that would hold me from using your way of doing in AL development?
For the Git part, there's no need to use the extension because with AL you directly work on the source files, of course. For the build part, you will have to adjust the script so that you download the symbols and compile the extension and stuff like that. But we also have that in place.
Because we're working in the hybrid situation where we have to build first the CAL part, and then parts that have been migrated to AL will also be built on the build server. Yeah,
makes sense.
So you can actually build anything related to NAV.
Question from Maurice Jennen, if I may, or maybe you get into that anyway. His question is, how do you merge Microsoft cumulative updates into your Git branch? Do you have issues doing that? Or is it
we're having a build that actually does the merge for us. So it will take the target version and create a Docker container of it, export all the text files, and then automatically do the merge, and we get the conflicts as an output, and we actually take a copy of that database, which is stored in VSTS, and we create the container based on that and solve the conflict. And currently that takes us less than a day to do that. So less than a day to merge our conflicts, even though we have a huge footprint.
Yeah, you do have. That's true. You're getting to the slide question and answer. Shall I continue with the next question?
Yes, go ahead.
It was actually the final demo. Yeah, we could fix the software and show a
green build.
Build, but let's move to the questions.
Yeah, there's a question from Dimitri Gatson. It's related to translation in AL. So you have this XFL file, which you can auto-generate while you build your AL project. Is there anything recommendation or let's say some tip of the veil from your side on how you handle translation?
I wish we could give that, but unfortunately Microsoft doesn't know this either. We also asked the exact same question to Microsoft and how to handle those XFL files in continuous integration.
There's a link on Jammer about it, and some subjects on Jammer about this topic. And LCS is one of the services that Microsoft provides that you can use for it, but it's not the process is not complete yet, so to speak.
So what we've done, we've kept XMLs in AL for now, and we're actually waiting for an automated way to handle the XLIFs.
Yeah, it's a bit, if you would put it in a Dutchism, it's still in kids' shoes, in children's shoes.
Yeah, exactly.
It still has to mature. It's typically something at, let's say, it wasn't conceived well or developed totally at the start. It's something they're still handling.
No, even at Microsoft, they also deliver some extensions, and Xlift part there is also not automated properly.
Yeah. By the way, your report, let's say, so your build, your automated build, and you showed you can have a look at the issues it's reporting. Did you also integrate that, or that's no? Yeah, I guess you integrated in your process also with a bug reporting thing that it automatically creates report on that. Is that something you definitely have to set up yourself, or is it something? Some things you can share with people that it makes it easier to get things automatically reported as a bug issue?
Yeah, we're still using Jira for our bug tracking system. So we migrated all the source code and builds, etc., into VSTS, and we're will be moving to VSTS also for the work items. At the moment, we're not yet there. But then, yeah, you can also, if a build fails, you could create a work item in VSTS automatically for solving the issue. Currently, we're just sending the email if it's an incremental build. Only the person that triggered the build will get an email. By the way, your feature branch is not okay. You need to fix it.
Yeah.
And for the full build, some stakeholders get an email that the full build has failed, which in normal cases shouldn't be the case, because we're already building incrementally, and validating everything there. But there are issues like if you're changing global functions, for instance, the NAV is changing the object names for you automatically. So in an incremental way, you won't see that change. Okay. So your build is successful, but afterwards in a full build it will fail.
For an incremental build, I wouldn't create a bug for a failing test, because it failed on the feature branch, and then you should also fix it there, in my opinion.
Yeah, you will notify that your pull request is not ready yet. So if you want to complete your item that you are having in progress, you need to complete your pull request.
Yeah. At a higher level, Max Sokolov puts a question. Actually, that's more generic than mine was. Is your build definition available somewhere to look at?
Ooh, not yet, at least.
Not yet. Okay, so I mean, it will be.
I'm not sure. What does he mean with the definition? Just the steps or the scripts, or?
Yeah, I guess the whole thing. I mean, the thing, of course, is everybody's getting more into this, and I've been on this voyage for a long time already, and it's always like everybody is reinventing the wheel. So the nuts and bolts that you can have a look at what somebody else has done already to make it easier to adopt it also. And
it's also it's also part of the next project I'm working on. That will actually solve that problem that everyone's having.
Yeah. Okay. Thank you.
We're on that hopefully soon. It's just a matter of time, actually.
That's always the case.
Yeah.
There's enough to enjoy and have fun with, but then finding time for it. Yes. So Max is also saying scripts mainly, but of course, any example.
I could share the demo scripts, but they're really demo scripts. They're not the ones that you would use for production builds, or it could just help you to set up, but it's not production ready.
A lot of the things in the scripts are we heavily use the commandlets for Microsoft, of course, the standard PowerShell scripts that are available, and the NAV container helper, of course, which also has a lot of powerful commandlets in it that we use. And some of the build steps are just native build steps in VSTS.
Yeah, we're getting to the hour, guys, and I think we covered a lot of questions also. Thank you very much, and of course, for those who haven't looked at. Wait, I wanted to show it in my screen here, but now I need to change something here. Yes, so I hope I can get it on my screen somewhere here. So this is actually Richard's blog. So if you want to keep following him, and well, I guess he promised to follow up on BAS, what it means and what there's more to it. So that's one to go. Summer season, so probably summer in September, and there's apparently also some scripts to be shared. Just pushing a little bit, but make a note of the navblog.com. Richard is always putting some very useful things out there, so follow him. Richard and Ron, thank you very much for having spent your time with us and sharing some of your daily practices. I think we answered all the questions that came around. So to all of you, have a nice evening or remaining part of the evening, or still a long way to go for the rest of the day. Have a great holiday season, summer recession, and we'll meet again at the end of August probably. Thank you all.
All right,
Okay.
thanks.
Bye-bye.